Hey everyone, this is my AE 2610 digital sampling slides report. I'm Karthik Chilkapati and I'm in lab section A03X. So introduction, the overall objective of these 3 weeks were to analyze various signals and to get familiarized with digital data acquisition. And we were trying to create our own experiment with this previous 2 weeks of experience. So why are we doing this? Because most experience involve time, so it's important to learn how to evaluate time varying signals, and lots of information can be extracted from getting samples of various audio tracks. So our approach over these 3 weeks, week one was just making sure our equipment worked correctly, so setting up the lab jack and verifying if our audio breakout adapters and microphone works. Week two, we had to identify 11 different audio tracks and note down the maximum frequencies and just use those audio tracks to extract more data. And then week three, we had to get frequencies from tone generators, and we also had a personal experiment. Here are the materials on the side. So week two results, these were the different types of waves that I got from the 11 different tracks and their peak frequencies. We can see there's a few sine waves, one triangle, one square, two noisies, and the last three are the special types of sine waves that we saw. For the track 7 and 8, which were both noisy, we saw that the sine waves were more like all over the place and not in a perfect sine wave, which was our identifying feature. Looking at these square and triangle waves, we can see that the square wave had a higher power than the triangle because it had to reach a certain VRMS for a consistent time, when the triangle wave just had to like touch it and go back down. Week three, here were the results from the jack and the mic power at these 5 frequencies that I chose. Relative responses were 2.262, 1.910, 2.923, 1.292, and 3.137 for these various frequencies over here. So in week three, the personal experiment, my motivation was that like I'm a piano player and I was trying to solve the problem of seeing the differences between a virtual piano and a live piano and how their frequencies differ. So the goal for the experiment was to basically find like different frequencies at different keys and see what the percent difference is between a online and a in-person piano. So the procedure for this, basically, I measured frequencies at 5 different keys on a virtual piano by connecting it to the 3.5 mm audio breakout adapter. And I also measured those same keys on that same octave through the microphone on my piano I have in my home. So using these two frequencies, I basically calculated a percent difference between these to see how accurate the virtual piano is. So our success criteria, if we get a low percent difference, that obviously means that we have the live piano is more accurate compared to is more accurate to the live piano, which is a good thing. And here is my data through the personal experiment. We can see we have the keys I chose were C, D sharp, F, G sharp, and B. And at these different keys, I recorded the frequencies here, as you can see. And overall, they were very similar. We can see a trend between both of the frequencies at these different keys. Obviously, as the notes went up, the frequency increased because we're increasing along the keyboard to the right. But at each specific key, we see that the frequencies are almost the same. Our percent differences are almost less than 1% for all of our different keys. So conclusions is that the online version is almost as accurate as the live piano because we saw a minimal percent difference in every single key that we tested, and the frequencies aligned almost exactly with each note played. But obviously we can also look at errors. Due to the results of the experiment, we could say that there were very low errors due to the high accuracy of our results. But there could be potential white noise from surroundings because I'm not in like a soundproof room, so like any noise in the surroundings could cause some sort of discrepancy. But I also live next to the roadside on my home, so car sounds in the middle could cause some sort of external noise. But our success criteria was proven successful because we did get a low percent difference. So overall, we did see that in the end, a live piano and a virtual online piano release the same frequencies. When comparing them, we get a low percent difference. Here are my lab notebooks. So we just have table of contents on the right, the objective equations and data required on the, no, sorry, table of contents on the left, and then objective equations and data required on the right. Here are my prior to week 2 notes, just seeing the trends in every single track that we were asked to look at. Continuing week 2 on the left over here, and then here on the right was when week 3 started. Up here were the 5 frequencies I chose for the beginning of week 3 and their powers at each part. And here's me writing down my personal experiments, motivation, and data. And that is all I have. Thank you very much.